Switching gears a little bit, I have an interview potentially coming up, so I'm going to be doing questions from the top interview 150 on LeetCode, focusing on ones that I haven't done yet before. So let's do remove duplicates from sorted array 2. Given an integer array nums sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. And then they give you this option where instead of shrinking the size of the returned array, you're instead going to return the size of your array. And that's another way that they're enforcing that you make your changes in place. So you are moving integers around in this input array, and then you return like where the endpoint is, whatever the size is. So if it's less than, they give this example 6, your output 5, so it means the first 5 slots will be judged. And then that's pretty much it. They give you a target space complexity of constant. So you can use like offsets and pointers and such, but you cannot allocate additional arrays. And then let's think about what the minimum runtime is going to be. Well, it's there's potentially duplicates. So suppose you have some input that's like this. Well, how do you know that all of these are duplicates of these first two without looking at them? So we're looking at least a linear runtime. Does it have to be worse than that? Probably not, because I think we can do something that's like iterative, increment, and like do some kind of almost greedy approach, kind of. Point is, we don't have to do like a nested loop that would turn it into a quadratic runtime. I'll just go ahead and write it out and then talk about some of the gripes that I have with it, but I can't think of a better way because there's complications that come into place. Okay, so it's pretty straightforward. It's gonna be, I guess maybe I'll do the example first. All right, so I'm gonna do this example starting with here. Okay, what matters is we're allowed to have 2 duplicate elements, so we don't really care about these first 2 slots. But then things get interesting starting here. What do we do? Okay. So let's say we have some low and high pointer. They're starting off, the same, whatever, there. Okay. Actually, I'm gonna jump to here, because this is where it will get interesting. Suppose we add these first 4 elements to our output array. That's fine, that's compliant. We got 2 zeros, 2 ones. But we don't want this third one. We want to skip that somehow. What do? Okay, we know that for sure the output, it will always match the first 4 elements of the array. There's really no way to have, well, no, I take that back. It will always match the first 2. And if the next ones are different, then that's fine. So in this case, these are different than these 2. So the interesting stuff happens here. Anyway, but we know that we want to skip this. So we've got this high and low pointer. What do? We want to increment this high pointer until it's something different. And then we want to replace this with this low pointer value with this high pointer value. But what are we going to check? We don't want, we can look back. How do we look back? Realistically, it ends up being, we're going to compare this 2 against, let's say like 2 before the low pointer. So this particular one here, we're going to compare this one against this 2. And if this 2 is greater, then we're going to overwrite this low pointer value there. And then we continue on. So increment. And you'll notice that they're not in non-decreasing order here anymore. That's fine because this high pointer is always increasing. And we want to make sure that at least like before this current low pointer, that it's always going to be in the sorted non-decreasing order. So we want to always be able to write this again. So that's why we're looking 2 back So if we look at this particular one in our conditions, it'll get kind of wonky. But if we look 2 back from there, so we have this 3. Did I increment too much? Hold up. Where's the point where I overwrote that one? All right, so we overwrote the one with 2. And then, so then maybe we, okay. I shouldn't have incremented this high pointer. Okay, so that's something to watch out for. If we do an overwrite, we're not necessarily going to increase the high pointer, or are we? Maybe we should. Anyway, we want to compare this 2 with now this one here, which is 2 below this low pointer. Okay, yeah, I think I have enough to start writing. Let's go ahead and write it out. So int equals 0, and that's going to be our low pointer. And I'm going to do a range for, so for int n in nums. And then if I is less than 2, because those first 2 we always want to add to our output anyway, or if n is greater than nums I minus 2, then we add our output. So nums I, and we increment after that, equals, and then that's it. That's the whole thing. Return I. Okay, let's continue on with this example. So we started off, we just overwrote this bad boy, and then we increment. Yes, we do want to increment them both. What did I do? So no, we overwrote this 2. Wait, hold on. I'm gonna start this example over to be a little clearer. Okay. Now that it's kind of figured out. All right, starting here. Okay. So we added these 2 first, and then our low pointer is going to be here. All right, low and high. So high pointer 1 is greater than this 0 here, which is 2 less than the low pointer. So we're going to go ahead and add that. So now we increment both of those. Same deal here, increment both of those. Okay, 1, this high pointer is not less than, it's not greater than this 1 here. So we're not going to increment this low pointer. So we only increment high pointer. And then same deal here. We're going to increment that again because that doesn't fit our condition. Okay, now we've got this single 2 here. And yes, there's only one single 2. Overwrite. Go ahead and do that, and then increment our low pointer. Increment the high pointer for the next iteration. And then same deal. 3 is greater than this 1 here. So overwrite. Overwrite and increment. And then same deal, 3, this second 3 is greater than this 2, this particular 2. So we're going to overwrite. Oops. And increment, except that's the end. This is the final one. So we break out of the loop, and then this remaining low pointer is the end of our output. That's it. So looks like 0, 0, 1, 1, 2, 3, 3, 0, 0, 1, 1, 2, 3, 3. That is our expectation. We don't care what those last ones are. And then I'm gonna go ahead and write the time complexity just to keep it documented. So O of n time and O of 1 extra space. We still, it's technically not possible to do less space complexity than the input because, well, it's going to take how much space it's going to take. But we use all one extra space. And that's pretty much it. I think that's good. I don't like this because it seems like a wasted check on every single iteration after the first two of this loop. But if you don't have it, then you start having to deal with edge cases of like, okay, then you have to initialize this to be the minimum of like 2 versus the size of the array if it's less than 2. And there's like additional logic checks that are kind of fiddlier to think about. And realistically, like this kind of thing, which it doesn't change the overall time complexity, it simplifies the code, so that's really the way to go. If they want you to dive into how to get rid of this, you'll certainly mention it, but if they want you to dive into this, they are killing time. They absolutely do not have anything else planned for the interview. They don't have a follow-up question. They don't have harder tiers of this question. And they're just like, okay, let's just keep going because I got nothing else for this guy. Yeah, or they might end it there if you're lucky, in which case, you know, that's good. Depending, most companies I think would take that as a good sign of like, oh, you solved it. There's no need to keep going. Stop the clock, and that's points on your review. Anyway, thanks. Let's go ahead and run that for syntax. No, what did I miss? What did I do? 1, 1, 2, 2, 3. All right, let's double check this. I minus. Oh yeah. I did the example looking at 2, but I typed it wrong. So that is a syntax error. Definitely meant to put a 2 there. There we go. All right, and submit. Cool, cool. And let's go ahead and check it off. Oops. Actually, I think it checks it off itself. All right, fair enough, fair enough. You folks have a beautiful evening.